お待たせいたしました。グリーンステージでの最後のセッションを始めたいと思います。
Thank you very much. We'll start the last session, Green Stage. My name is Ishida from Global Environment Group of JICA. Latest technology services that contribute to development in developing nations and also introduction of a technology will be covered in this speech session. 12 organizations and companies will present their technologies, products, and services. 9 minutes are allocated to each of the presentations, including Q&A. So at 9 minutes, the microphone will be handed over. Tsubame BHB, KOMAIHALTEC, MZ, ExtraBold, TBM, Hemicellulose Ltd, Japan Technology Development, Food REBORN, ALNUR, Clean Ocean Ensemble, ALNUR, and fabula. We will be hearing presentations in this order. We'll start with Tsubame BHB.
Good afternoon, ladies and gentlemen. My name is Hiromi Suda. I'm in charge of business development at Tsubame BHB. It's a great honor to be here to present our business and technology to the distinguished industrial leaders from all over the world. Feed the world and feel the world. This is our slogan. We are striving to achieve food security and decarbonization using our unique technology. So please let me introduce our company in 3 keywords. We are a startup born from Institute of Science Tokyo. Number 2, we have an innovative ammonia synthesis technology called LX-ready catalyst, which I'm going to explain you later on. And number 3, using our unique technology, we are deploying flexible and distributed ammonia production system worldwide. Before I explain about our business and technology, I would like to touch on a bit about ammonia. Ammonia is a commodity chemical, and almost 200 million tons of ammonia is produced in the world every year. Ammonia is an essential feedstock for fertilizer and other industry products. But I would like to stress more than 80% of ammonia is consumed for the fertilizer production. But now, ammonia is expected to play an important role for our world decarbonization. Ammonia is expected to be used for maritime fuel, power generation, as it doesn't emit CO2 when combusted. And also it is expected as a high potential hydrogen carrier for the decarbonization of so-called hard to abate industries. The world population reaches 9 billion in 2050, so we need more fertilizer and more fuel, which means that we need more ammonia. However, ammonia industry has 2 issues. Its production is now limited in fossil fuel-rich countries, and there are significant amount of CO2 emission in its production. Nowadays, ammonia production is limited in fossil fuel-rich countries. The pink circles in the map shows ammonia production site and its volume. Other countries are dependent on import for ammonia and ammonia derivatives like fertilizers. And the other big issue is that the current ammonia production is from natural gas or coals, therefore emits significant amount of CO2. We have 380 million tons of CO2 emissions every year, and that counts for 1 to 2% of the world's total CO2 emission. To tackle these issues, Tsubame BHB drives transformation of ammonia production. The keywords are distributed production and green ammonia. So I would like to talk about our core technology, how we are going to achieve our visions. So our core technology is an innovative ammonia synthesis catalyst named electrolyte catalyst. Electrons contained in the catalyst performs as negative ions, and it enables ammonia synthesis at lower temperature and pressure compared with the conventional technology. Ammonia synthesis under mild condition has high potential to reduce its energy consumption and plant cost. Using this unique technology, we offer flexible ammonia production responding to the client's needs. For those with relatively small demands, less than 100,000 tons per year, we offer distributed modular type ammonia production system, which we are mainly targeting fertilizer local production or industrial uses. And the photos here are our first modular system for 500 tons per year production, which is now under installation. And for those requires large-scale production from 100,000 and above, for fuel and energy purpose, we offer a catalyst and basic design, which we target to launch in 2030. So today I would like to introduce low carbon fertilizer production model. We generate hydrogen from water and nitrogen from air, then synthesize ammonia using locally available energy, renewable energy. Then we transform ammonia into fertilizer in whichever forms required in each country. Anhydrous ammonia direct application is common in North American countries, but the rest of the world prefers liquid or particle type of fertilizer. This is the image of our low-carbon fertilizer plant. You can visit our VR plant from our website, from the QR code here. Thus, our flexible and distributed solution enables ammonia and fertilizer production in demand area. So we can mitigate the client's global supply chain risk and also contribute to the significant CO2 emission reduction in its long-distance transportation. And also producing ammonia with locally available renewable energy, we can graduate from the fossil fuels and reduce large amount of CO2 emission from ammonia production. So far, we have already received 2 commercial plant orders in Japan. EPCs are ongoing, and the first plant will be on stream in August this year. And the second one follows 1 year later. And we have many project development discussion with global partners. So we are very happy to be connected with the partners to develop this low-carbon fertilizer project in your country. Thank you for your attention.
ありがとうございました。続きまして株式会社
Thank you very much. Next is KOMAIHALTEC.
こんにちは、KOMAIHALTEC の中島と申します。
Yes, this is Nakajima with KOMAIHALTEC. Thank you for the opportunity to introduce our company and technology.
それではまずはじめに、私どもの会社の紹介をさせて
I will start with the introduction of our company. The company was founded about 100 years ago, and Our company has been involved in infrastructure, bridges and steel frames as manufacturer of steel bridges and steel frames. There are three key business areas. One is bridge design, installation and maintenance, and two is steel frames and steel structure production. And the third business is environmental business, manufacturing of medium-sized wind power generation for renewable energy. We haven't been doing this for the past 20 years. Our energy business is based in Futsu, Chiba Prefecture, and Osaka. In Futsu factory in Chiba, we manufacture materials for bridges and steel frames, and we have renovated part of that. And we are now building a production line for offshore wind turbine towers. And in Osaka, we are manufacturing middle-sized wind turbines. And this is the introduction of our products. 300 kilowatt wind turbine models. Three different options. First one is the normal climate. Second is for cold climate. And the third one is a typhoon area. So 33 meters rotor diameter, hub height is 41.5 meters, and nacelle weight is 18 tons, small size. We have strong winds in some parts of Japan, and roads can be quite narrow. So we are making products and parts that are easy to transport and install. For example, this tower can be separated into 4 different sections, which makes it easy to transport. And also, installation usually requires 200-ton size crane, but we have a self-lifting system that we have developed ourselves. Using this, you can install the wind turbine using a 60-ton crane instead. In addition to the 300 kilowatt, we have 1 megawatt model, which has been developed. We know that the size of the wind turbines are getting bigger. And for on-site power generation, we know that the demand is growing for wind power. So 1 megawatt wind turbines, we believe, has a big market. Again, we have the typhoon resistant type, 91.26 meters per second, withstanding winds up to this speed. We are doing prototyping now, and we expect commercialization from 2025. Let me introduce you some of the projects. This is a Mie University in Mie Prefecture and campus power generation. They use solar power, battery, gas engine, and stabilizing equipment in combination with our turbine. And this is the smart campus concept. This one is in Kanagawa Prefecture, Miyakawa Park. And wind power is used to power the lighting at night. And this is also a landmark for the local residents. This is an on-site use, Shizuoka Prefecture, food factory. 100% of the power used here is generated using renewable power. This one is Miyako Island in Okinawa. Type test is being done right now for the typhoon-resistant model. This is an overseas example. Two examples in extreme cold weather. Fuel transportation can be very expensive, so renewable energy and combining with diesel fuel power generation, very stable power generation can be achieved with a lower cost. These different sites require various types of solutions depending on the scenario, depending on the situation, and we can be flexible. This is in the Philippines, and the environmental agency's grant was used for this project. Diesel power plant and our wind power were combined, and the power generated is used to power electric motorcycles by Honda. ABB financed this project in Bhutan. Very narrow roads leading up to this small village in the mountain area. And they had to carry the parts components for the wind turbines up there. We have knowledge about wind and the steel structure, which enable us to create systems to support solar systems as well. There are two examples here. One is high pole sky solar, and the other one is cable suspension sky solar, utilizing the capabilities for cable bridges. And these are some use cases for agricultural land as well as water. And this is an example in Komaihalte city. Solar panel placed on top of a reservoir. This one is in Fukushima Prefecture, parking space, equipped with a solar system. And there's a lot of snow in this area, so we have changed the angle of the solar panels to make sure that it can withstand the snow. And also there is a snow melting device attached to this as well. This is a cable type system and the demonstration project in Matsuda. Even if there's a steep incline, or even if the space available is small, right next to, for example, a farm area, you can still use this option to install solar panels. As you can see, we provide a whole variety of different systems and solutions suited for each situation of our customers. In planning, design, construction, maintenance, we can do everything. With regard to maintenance, we know that some customers prefer doing maintenance locally, in which case we can also provide services to educate the local player to do the maintenance as well. If you're interested, please let us know. Thank you for your kind attention.
Thank you very much. Housekeeping announcement. There are some empty seats towards the front row, so please come towards the front. You will be able to have a better look. So from MZ Corporation, the floor is yours, please. Hello, everyone. From MZ, my name is Ishida. Thank you very much for this time today. So I am very honored to be able to have this opportunity to speak in front of you. Thank you very much. For carbon, in terms of initiative of the regulatory requirement, this is showing the regulatory framework. For carbon, CFC, HCFC, HFC, there are several of them. And out of that, CFC, it's CFC. the Montreal Protocol in 1986, and this has been stipulating the framework of that. No utilization of CFC, but HCFC for developed country is banned by 2022 and developing countries by 2030. So now it's utilizing HCFC. But we are gradually going to reduce the utilization of this fluorocarbon. And HFC, the utilization, the status quo, and the future is summarized on this foil. First of all, on the top graph, the line graph, HFC recovery rate. And overall, on the right-hand side, it's clear about 40% is being recovered. So in Japan, 40% are being collected. And 40% sounds as though it's low, but globally speaking, it's quite high in terms of recovery rate. And below, blue and red bar graph, this is collecting the fluorocarbon and then destruction and also utilization of that. Red is destruction and blue is reclamation, so reuse of that. As you can see, the reclamation rate is about 30%. Then, so overall, the 40% being recovered and about 30% can be reused. So you will see that the overall numbers are becoming smaller. Top right is the recovery of, well, we have alternative fluorocarbon. So the refrigerant after the fluorocarbon, many companies are utilizing that method, and this is the development phase. Still yet, there are many, of course, fluorocarbon, but a lot of green refrigerant, but there are some odor or the sort of a combustiveness. There are some issues that still need to be tackled. So HFC, the trend is on a decline. So this from the reclamation, utilization of the collected, recovered fluorocarbon. So F-gas, so you collect them in normal time is 60-70 collection by construction companies such as General Construction Company. But in terms of when we recover and reclaim, is 98%, very high. In terms of reclamation rate, the reuse rate, because the right procedure and right tools are being utilized. And through that, we have high ratio of F-gas to be recovered and reutilized. And this is just a reference. F-gas, collecting, recovering, and then reclaiming. The reclaimed F-gas, what's the situation? How much are being used? This is a traceability, and we need to manage them. So our company have a system called RefNext. Utilizing RefNext, the F-gas could be managed from recovery to the reuse to be reclaimed. So if you're interested, please let us know. We will be able to share with you how this system works. And following, this is the recovery or collecting is important. So unless you recover them well, the reuse will not go up. So this is the content of the procedures that has been undertaken. It's in English, so it may not be clear. But for us, the ISO, the three dot in terms of 9001 2015 is a certification that we have been certified. So for all time, we analyze the content and then try to reclaim them. So that will be the basis of the reuse. So as you can see, 95 it's small, but 99.5% we are now utilizing them. So the reutilization of F-gas, there may be a concern about the quality of the F-gas, but for us, 99.5% above, the raw carbon gases we would be able to reclaim or reuse. So these F-gas and reuse of that overseas for developing countries where F-gas is not left without being collected. So we also like to run an initiative outside of Japan. In Vietnam, Maria Buntao State, we have a new company that we have established. So F-gas, as you can see, from the customer brings to us the non-already used F-gas. So we visit a customer and we collect F-gas. So first of all, it's collection of F-gas, and then as I explained, the reuse technology that nurtured here in Japan, we try to reuse them. And also, last but not least, our collection of F-gas is a theme of our business, but alliance with the stakeholders or party involved is essential. So at the beginning, when you think about collecting F-gas and the consumer and collecting the F-gas and us to deliver the goods to us, and we like us in order to make the F-gas to be reused. Everything could not be reused. So I mentioned about 30% could be reused. So everything will not be reused. So there are area where we will need to discard. They're discarding company and extracting F-gas. Then the machine need to be recycled. There needs to be a company to recycle these. So every company and parties need to cooperate so that we'll be able to robustly collect on F-gas. So for us, in terms of F-gas that we're going to reuse, these are the effort that I would like to have you join on the journey so that we'll be able to share and feedback the F-gas that could be reused once again. So it has been very brief, but if you have any questions, please feel free. We have emails and home pages available. So thank you very much. Thank you once again.
ありがとうございました。続きまして株式会社
Next is ExtraBold.
Hello everyone. I'm ExtraBold. 日本語言いましょうね。すいません。私ExtraBold の CEO.
I'll switch to Japanese. I'm a CEO, CTO, and founder of ExtraBold. We develop and sell larger 3D printers for any materials. And we are also researching technology for material innovation. And we also have creators. We have a strong network with creators. And we want to use creativity to solve environmental issues. 12 feet size, extra large 3D printer. This is what we offer. And also, world's first collaborative robot-based 3D printer have been developed, and it is being sold by us. Fast, choice of different materials, and you can make something big. These are the characteristics. Last year in Thailand, our printer was used to make material for the parts of this racing car by Toyota. And our materials are used for interior structures, organic-looking interior structures, for example, and also very sleek-looking wall can be made by 3D printer. Everything can be recycled. So you can combine with a recycle machine, you can use our printer, and this kind of recycle is already being achieved. This is a reality already today. Organic waste and recycled materials can be used to make new materials. I'll skip the difficult part, but we have level 1, 2, 3, 4 different levels of material making. Let me explain one by one. First of all, we have level 1. Water server tank. These big plastic bottles can be pelleted and turned into something else. This is a very fashionable looking lampshade. This was designed by our own engineer/designer. Imabari City is using our technology, including a printer. Road cones, these triangular cones, can be pelleted and turned into Christmas tree ornament. This one ornament can be made in about 2 minutes. Another example. If you have in-house waste, for example, within the company, when we make something in-house, what we make is provided free of charge to the employees. We use marine waste like this. In this case, we're using mandarin skin. When this is turned into powder, you can actually mix it with other materials. Anybody can do this. You don't have to be an expert. So students and employees try to find more different materials for recycling and upcycling. So this is something that we tried with Toyota last year. All sorts of different residual wastes are included. For example, Lego block from your childhood, which means that each material can have a story for different individuals, which means that the product that is made from the material definitely has higher value. That's level 2. So Hiroshima City University student made this in 2 days from marine waste and wood waste. So manufacturing and creativity, if the young generation these days can master both, they can be really creative. This is MFU fusion. MF fusion. So this is a Japanese technology that mixes different materials with plastic at high melting point. In this case, tea leaves, used tea leaves is used, so you can smell tea. If you use coffee grinds, you can smell coffee out of this. Again, another added value. You have no idea what is here, but this is a CD, DVD case, and also wine residues. You can mix all these different materials and manufacture chairs. So material technology and 3D printing technology combined. And more recently, I don't know how is it right now, but Japan has a great technology, and we're working with that startup. CO2 can be turned into charcoal, and 60 to 70% of the CO2 can be captured. And you can use plastic waste, and food waste can be turned into biocharcoal, and you can also generate power through this process. You can use CMF, cellulose microfiber, and make a combined material. This is a type of plastic that is more resistant or stronger than the traditional plastic. So we are trying to introduce more added values for social implementation while moving away from 3D printer. Large general contractor is working with us in Thailand for this. So biochar is made, and then you can mix it with concrete. That absorbs a lot of CO2. I didn't know that that concrete actually emits a lot of CO2, about 80% of the volume of the concrete, but using this process you can reduce the CO2 emission. So various demonstrations have been done through the power of creativity. Concept model for car OEM and the startup making this kind of interior materials, and this green thing, for example, this is a beautiful product. I will talk about this later. And also wood chip based interior. This is a counter table using wood plastic by Mitsubishi Jusho Sekkei. And concrete 3D printer, you can actually make a house within 1 day. But if you try to do interior, it could take 6 months, but we can make it faster. And this is the product. These are the 3 members of our company. And Milano Salone is like a global design competition, and they won. And all of them left the company, and they're independent, but they're working with us now. So sustainable technology plus printing innovation. You can do this much by this combination. We want all the different industries to know about our technology, and we want more people to know about this technology so that we can together create more sustainable products for the world. Global South Aid, the grant, we obtained that the other day. And Japanese technology can be brought to Thailand to solve environmental issues and change the society with the power of creativity. We already have some customers already. And this is a membership model. The companies will come to this site and use what's available there. And we will do different types of demonstrations with these companies. Because in Thailand, if you want to make an interior piece, for example, you don't have to comply with the fire code. So it's easier to try this in Thailand and bring this back to Japan. So we will make this material center in Thailand. In Thailand, there is a Takashimaya department, and last year we had a 3-week event. We brought our 3D printer and did demonstration, manufacturing, and selling of the products on site. I would like to show you the video. I think it's about 1 minute.
こちらですね。先ほどのほのかのチームってこれ実は畳の残差です。40%。
This is the video. This is made from residual from the tatami mats and biodegradable plastic as well. Very expensive, but we sold many. Even a small vase like this would cost 20,000 to 80,000 yen, but they sold very well in Thailand. We had famous people from the embassy. We had a very famous actress from Thailand, and because of that actress, this campaign was helped a lot. We want to mainstream the tools for solving societal issues without making it too difficult for people, too academic to people. And we are looking for financing partners as well. That's all for me. Thank you.
Thank you very much. Now I would like to invite from TBM, please.
Hi, good afternoon, everyone. My name is Minori Kitagawa from TBM, and today I would love to introduce our TBM and also our products, two main business, Limex and also circular material circulation. So TBM stands for Times Bridge Management, and we established in 2011. So and we have more than 300 employees now, and we have 2 factories in Japan. So first one is Tohoku Limex factory, located in Miyagi Prefecture, and second one is Yokosuka Circular Factory in Kanagawa Prefecture. So our business is, we have 2 main business pillars. So first one is Limex. So to realize the decarbonized recycling-oriented society, we encourage the using new environmental friendly materials called Limex, and which is mainly made from limestone. And we also have another business, and resource circulation business. So let me explain about the Limex first. Limex is an inorganic filler composite material which can be alternative for the plastics and papers. So Limex contains more than 50% of calcium carbonate, and we use the plastic resin as a binder. And Limex has 2 types. So first one is Limex pellet, which can be the alternative for the plastic. So it could be processed with the blown film molding and thermoforming, injection molding, blow molding, spun bond. And also we have Limex sheet, which can be the alternative for the paper. The reason why we use the limestone is it's really abundant natural resource worldwide, and also limestone itself can reduce the CO2 emissions, and limestone is economical because it's abundant, and also the price is stable. Environmental impact of Limex is, as alternative to plastics, it could reduce the oil consumption and also greenhouse gas emissions. And as alternative to the paper, you can reduce the water consumption by 97% compared to the paper. And you can save the forest because Lamex doesn't need any pulp, and we manufacture the Lamex using 100% renewable energy. Lamex has been introduced more than 10,000 companies and municipalities in Japan. So I think many of you have already seen these brands and companies. So actually the Lamex is everywhere. And it's not only in Japan, but we have the global symbolic cases of Lamex. So JCCI Co, it's a French advertising company, and they adapt the Lamex for their backlit signage. And Li Weiwei, they are famous of its Oishi brand, and they are using the Lamex for the flexible packaging. And also Big Shi, that is a Thailand supermarket, and they also adapt the Lamex baskets. So here's the new topic of the Lamex. So at TBM, we are so excited to announce that TBM succeeded to develop next generation Lamex. Its brand name is GR Lamex, which stands for Carbon Recycled Lamex. So Carbon Recycled Lamex is a low carbon material that promotes carbon neutrality. Conventional Lamex uses the calcium carbonate, which is derived from minerals. But GR Lamex, however, replaces it with calcium carbonate, which is chemically synthesized from emitted CO2 and calcium-containing waste, such as concrete sludge or the steel slag from factories. So together with GR Lamex, TBM is taking the next step towards even more sustainable manufacturing. And I move on to the material circulation business. So TBM is promoting the material circulation from a multiple perspective. So first one is trading waste plastics. So we matching the business of waste plastic discharged from business establishments. And second one is material circulation digital platform. So TBM, we have our own service to visualize the traceability and environmental impact by DX. So we support efficient procurement and buying, selling of recycled plastics. And third one is recycling factory. So I will explain about more in detail later on, but we have the mechanical recycling factory in Japan, and it was established in 2022. So it's been only 3 years, but we have already have the recycling record in Japan is 17,000 tons per year. And finally, we also do in the development of final products, which has the high added value final products. So here is the explanation of the Yokosuka Circular Factory in Japan. So this is the world's first plant to collect and select general purpose plastics like PP, PE, or PS, and also the Lamex as well for recycling. The process is we collect the plastic waste from the office and factories, but not only the industrial waste, but we also collect the waste from municipalities. So we receive the plastic processing fee from those municipalities and collect the plastic from the households. So in this factory, this is the whole process. So PP, PE, or PS is sorted automatically by using European technology. In addition to that, the Lamex can be also sorted in this process. And sorted plastic can are crushed and washed. And also they are separated depending on their specific gravity in this process. And finally, there are 5 pelletizing lines in this factory. So an automatic self-cleaning screen changer can remove the contaminants. So our recycling plants in Japan adopt the dual income system, receiving the plastic processing fees from the municipalities and revenue from selling recycled pellets. So understanding that not all regions offer municipal support, so TBM is taking a different path. So with our cutting-edge Lamex technology, we are enhancing the value of recycled plastics and driving sales to build a self-sustaining business model. So we are looking for visionary municipalities to collaborate with us, and also on this journey towards a more sustainable and financially developed independent recycling ecosystem. Yes, and TBM launched the Resource Recycling Council as an organizer. So we understand that we cannot achieve the circular economy by ourselves. So we need more cooperation with other entities. So together with more than 190 members from corporate, startups, financial institutions, governments, this Resource Recycling Council will carry out the policy recommendation and also the social implementation of the circular economy. So at TBM, we realize the sustainability revolution with you. Thank you so much for your time.
ありがとうございました。続きまして株式会社ヘミセルロース様。
Next is Hemicellulose. My name is Asukawa from Hemicellulose Ltd. We develop and manufacture functional materials from wasted plants and trees. Hemicellulose, this polysaccharide, is used for functional materials such as plastic and adhesives, and we were the first to develop this. We have an international patent. These are the three substances: cellulose, hemicellulose, and lignin. These are found in the trees and the plants. And cellulose is used for paper pulp, and the lignin is used for biofuel. Hemicellulose structure and nature is different from tree to tree or tree to plant. It was quite difficult to use. So most of the hemicellulose was just burned, not really utilized. About 50 billion tons of hemicellulose is emitted or wasted globally. So we wanted to utilize that. So in terms of soil marine biodiversity, it's excellent, and also it is excellent in terms of molding. It is easily molded. There are three social issues that we need to solve. 50 billion tons of hemicellulose is produced. Maybe by utilizing this, we can stop global warming. And the second is food loss in the urban area. Food waste and also waste coming from food factories. This is also high in volume, and using our technology, we will be able to reduce these wastes. And thirdly, in the rural areas, there are sometimes husks and residues that are basically byproducts of agricultural manufacturing, which is usually discarded, but we believe that this is also natural resources that we can take advantage of. Agriculture, chemistry, biology, molding, we need different types of experts and engineers to work on this. And we established a process to develop products from the plant extracts, including chemical reaction, formulation, compounding, everything. We are an agri-tech, original agri-tech company, because each plant is unique. And for each uniqueness of the compound or substance, we have different ways of dealing with that, different processes. Cacao, coffee, barley, wheat, corn cob, and bagasse. We have different processes for each. So 100% plant origin, biodegradable, friendly to environment, and also very highly functional for automotive use, for example. In this case, we combine with a petroleum-derived material as well. So we provide, we are also developing fibers and textiles. 100% natural is not really available, but we are trying to achieve that. Foundation in cosmetic industry is causing problem in the ocean with microbeads. But we are developing something that is an alternative, which is more natural. CO2 reduction is about 30 to 60% higher compared to fossil fuel-based materials. Now, marine biodegradability. Within 1 month, 90% or more can be degraded at the fastest. But we also have technology where we can retard that degradation as well. Ease of use, ease of manufacturing, and strength and heat resistance similar to fossil fuel-based material would be required for commercial use. So we are also working on those aspects. We develop in-house. We're very quick. And also we have a variety of approaches for different types of materials and small capital investment. Only small capital investments necessary. Ecuador in South America, Amazonian forest is being depleted, but in order to stop cutting the tree, we were asked to make use of the seeds rather than cutting the trees, and including aspect of donations. This is expanding. Cacao is another global issue. Cacao is used for chocolate, but only 5% is actual cacao. The remaining 95% is husks and wastes, which we are trying to turn into useful materials for different characteristics that are needed for different products. Sometimes I need to make the material very thin, sometimes very thick, sometimes very strong. So we are going beyond the world of chocolate. We are going into toys, ballpoint pen, apparel, and others. We have a global cacao initiative. Ghana, Ivory Coast, Madagascar, these are the producers, and also poor countries. In order to make them richer, they could manufacture this material locally and then export to Europe, for example. In South America, they can manufacture locally in South America and export to the United States. So that's the overview of the company. TCAT 9 in Yokohama. We will be doing some presentations there as well. So please look forward to that, and thank you for listening.
Thank you very much. Now, from 8, we would like to invite Japan Engineering Consultant, Japan Engineering Consultant, please.
Okay. Hello, everybody. I'm Kotoe Kuroda from 8 Japan Engineering Consultants, or EJIC in short. I'll be presenting about our environmental consulting services for creating valuable forests and cities for the future. First, let me introduce about our company. EJIC provides civil engineering consulting services to create a valuable environment for the future. We have 70 years of history and over 1,000 employees. Our parent company, EJ Holdings, set a 1.5 degrees trajectory-aligned greenhouse gas emission target and is working on climate change across affiliated companies. Regarding international projects, we completed over 700 projects in over 70 countries since 1970. Okay, so now that you know about EJIC, I'd like to introduce to you some of our projects which are related to creating valuable forests in cities. I've selected 4 projects which are aligned with the topics discussed in the blue stage of this seminar. So related to urban climate action and synergy, I'll introduce about environmental, social, climate considerations in civil infrastructure projects, as well as a feasibility study and development of an ecotown plan. Related to collaboration and circular economy, we'll introduce about our subsidiary company, Naka Wood's wood powder and products. Finally, related to waste management, we'll introduce about our surveys for planning waste-to-energy plants. So now let's start with environmental, social, climate considerations and projects. Every year, we implement multiple civil engineering projects. Many of our international projects are commissioned by JICA, which is our host today. In JICA projects, we follow JICA's guidelines and procedures to ensure environmental, social, climate considerations. So this is an example of the Nagadunga Tunnel, which was the first mountain tunnel ever made in Nepal. And it connects the capital city of Nepal, Kathmandu, to neighboring cities. In Nepal, the increase in heavy rainfall due to climate change are causing frequent landslides, which in turn lead to severe road closures. The Nagadunga Tunnel is expected to be utilized as a means of transportation that is not affected by such natural disasters, while also improving traffic congestion and reducing accidents. It will increase the resilience and connectivity of cities while contributing to the economy of the area. The photo on the right shows the tunnel being used as a passage for emergency vehicles and over 2,000 residents when a mountain road section was closed due to a landslide last September. And this was even before the tunnel was officially opened. EJIC was involved in most of the project period, from reviewing the initial alignment plan of the tunnel to the survey, design, and construction supervision stages. And in the survey stage, actually, Otani-san, who is just sitting there, he conducted the environmental and social consideration survey and ensured that groundwater compensation for agriculture and the local citizens living were given. Next is another example of urban climate action and synergy. So valuable cities can be made with smart, green, and resident friendliness. This is a development plan of an industrial ecotown in the suburb of Bangkok, the capital city of Thailand. We conducted the feasibility study and made this development plan with local partners to make it a valuable city. We planned for the ecotown to have environmental conservation and restoration areas, green infrastructure structures such as flood countermeasures using mangroves, and waste-to-energy plants providing electricity to industry and households, and we also installed this material recycling facility. Next, related to collaboration and circular economy, I'll introduce EJIC's subsidiary company, Naka Wood, which is located in Nakacho, Tokushima Prefecture, where the forest coverage rate is 95%, and the planted forest rate is 78%. Naka Wood owns and operates a wood collection station and processing plant in Nakacho. Through the utilization of wood and environmental education activities conducted in collaboration with various stakeholders, including the local government and local businesses, Naka Wood aims to conserve the natural environment, enhance national land conservation functions, and realize a sustainable circular society. Naka Wood makes wood products such as cutting boards and surfboards using locally sourced wood. Naka Wood also makes wood powder called mokufun by grinding locally sourced discarded timber and thin wood. The wood powder is used to make products such as bioplastics and portable toilets. By replacing materials into wood, we can reduce carbon emissions. Also, by using wood, we can vitalize the local forest industry. And with more forests being managed, floods and landslides in the area can also be reduced. Nakawood also conducts various environmental education activities and trainings for children to adults. Recently, JICA trainees from Nepal visited Nakawood to learn about sustainable forest management. Now, this is the final case study I'll show today. This is EJIC's Solid Waste Management Division. So our Solid Waste Management Division supports local governments in all stages of waste management by providing services such as master planning of waste management, facility concept design, public-private partnership, PPP, or private finance initiative, PFI, applicability studies, procurement advisory, supervision of design and construction, and operation monitoring. We have conducted over 3,000 waste management projects in the past 50 years, of which 70 are overseas. This slide shows one of our many services, and this is the Waste Analysis and Characteristics Survey. We also call it WACS in short. And this was recently conducted in the Philippines and Indonesia. WACS is an essential survey when developing a waste-to-energy plant. It's needed to understand the characteristics of the waste that is generated in that target area. And this helps to develop efficient facilities and is used to calculate the income from the energy generated in the waste-to-energy plants. Oh, sorry. Back to the original. Okay. And we also pretty much value the preparation stage of making a waste-to-energy plant. So we also conduct time and motion surveys of waste collection trucks to understand the waste flow in the target area. We also study the trip tickets of incoming collection trucks to know where each trucks collect their waste from. In Japan, WACS studies are conducted regularly, even in the existing facilities. And we believe that as more countries are considering waste-to-energy plants, such surveys will be required all over the world. And EJIC is willing to support these future WACS projects overseas. So that's all from us today. Thank you very much for your attention. And for more information, please do check out our online pavilion and feel free to contact us later, maybe in a networking event or through our email. Thank you very much.
ありがとうございました。続きまして株式会社フードリボン様お願いいたします。
Next is Food Ribbon.
こんにちは。フードリボンの代表取締役の宇田と申します。
Hello, my name is Uda, Representative Director of Food Ribbon. We want to create tomorrow where there's no waste. And we have unique technology and business model to achieve a circular economy. And we would like to share our vision and challenges today. In 2017, the company was founded in Okinawa, and we are moving from Okinawa to outside of Japan. 92 million tons of clothing are discarded every year globally, and 35% of marine microplastics come from chemical fibers released during washing. Human activities are impacting the environment more and more, and it is now exceeding the planetary boundary. 95% of food production depends on soil, but 38% of the world's soil is being degraded. This is, in particular, a big problem. Our livelihoods are supported by soil, water, and plants and animals. But currently there is constant shortage of water and nutrients. We have to change our mindset to change this situation. And recovery of this Earth environment is the biggest challenge. And unused materials, resources need to be utilized. And we want to change people's mindsets and awareness through these activities and recover the nature, strengths of nature. And leaves of pineapple plants are unused, unutilized. So the first thing that we wanted to do was utilize this. This is the project overview. We have developed the fiber extraction technology and also saccharification technology, enzyme extraction technology, and a tanning line technology. We have a comprehensive circular model. Water jet is used to extract fiber, and based on this technology, we have created many valuable products. We also use residue from the fruit as well. And this helps farmers become more independent and industries to use reusable materials. So fiber, bio-based materials, and cycle, these are the three aspects of our business. Fashion, food, railroad, hotel, we are collaborating with all sorts of different industries. In the life cycle of clothes, approximately half the CO2 is emitted during the raw material sourcing. We use the fruit byproducts to source the fiber, so there is no additional farmland required, and there is no competition with the food manufacturing or food production. There's approximately 30 million tons of global natural fibers. But if you look at the unutilized resources such as pineapple fiber, there is again another 30 million tons. So this should be a meaningful option to use these unused or underutilized materials. Linen flax fiber is mostly made in China and Europe. Needs is increasing, but the price is high and the supply is limited. Pineapple fiber can be sourced in most of the southern hemisphere, including Asia, Africa, and South America. Pineapple and banana fibers were used with traditional technology, but the quality was poor because only thick fibers could be extracted. Thin, fine fibers were lost. Therefore, it could only be used for thick materials. But we are able to extract thin fibers and thick fibers separately from the same pineapple leaf. So we can extract softer fibers. So instead of using this material for denim and thick fabrics, we can now manufacture t-shirts, sheets, and towels, something softer and more lightweight. So towels, interior fabrics, different types of applications are possible. Automotive interior, surfboard, and also alternative for carbon fiber for aeroplane use is also being considered. Panasonic has a Kinari series. We developed a tumbler together with Panasonic, and these straws are used by more than 200 companies and shops, mostly in Okinawa. We don't just provide fibers and biomaterials to the manufacturer. We have built the whole structure of circulation. So manufacturer, business, customers, everybody is connected, and whatever's used can be recycled. So circular society can be built on the platform that we provide. That is the aim. Last year, we established the head office in Okinawa. So this is a new site for the business as well as education. Last May, when this was opened for the open ceremony, many people participated. SDGs experience program and also training are provided from this facility to increase employment locally. In Indonesia, we have started a plant. The fibers extracted and then supplied to textile manufacturers. People young people who work here are proud and have a bright hope for the future. Mangkunegaran Royal Palace, a king decided to introduce this program. And the black jacket worn by the king, the royalty, is made from pineapple. Batik is a traditional industry, and the garments worn by the royal family will be made by the pineapple fibers provided by us. In 1 year, 1.5 times increase in the revenue can be achieved. CO2 reduction, water use reduction can be achieved. So we can contribute greatly both for business and the environment. We want to expand this program globally in order to solve societal issues around the world. And this is the vision for the future. Up till now, we have been building the foundation. But toward 2030, we want to achieve 5% of global natural fiber market. And after Indonesia, we will be going into the Philippines and into ASEAN region, and then Europe and the United States. Food Reborn has many people working for us with great hope for the future. They're the ones who are really driving this organization. And I really appreciate the fact that we could share a future vision with you today. If you're interested, please let us know. Thank you.
ありがとうございました。続きまして、
Thank you very much. So, ALNUR Corporation, please. Thank you very much for today. My name is Yoshika from ALNUR. So far, listen to the presentation. There are various kind of initiatives that are being undertaken. I'm very encouraged and I feel very happy. And we are, first of all, utilizing red seaweed, and cow will help us help the world. Red seaweed saves cow, seas, and the planet. So it's a big theme of ours. So my relative, so when I talk about red seaweed and cow, they always ask what's the relationship between these two. And there's no relationship that's not obvious at the least. And I would like to talk on this theme from here onwards. Well, we are ALNUR is a project called Kagi no Wa. And in terms of the future of cow and seaweed, it's Kagi means key, and Kagi no Wa is the name of a project. So first of all, so seaweed, algae, how they would save cows, seas, and planet. And just to give you a background of that, first of all, the global warming is the GHG, the greenhouse gases. So it's carbon dioxide, methane, nitrous oxide, those falling gases, the four gases. MC group also have mentioned about F gas is the main reason for the global warming. And 75% in terms of CO2, methane is 18%, and following that, in terms for carbon and nitrous oxide is also follow. And this number be next to it is a global warming indices. So if carbon dioxide is 1 and methane is 25 and nitrous oxide is about 300, hydrofluorocarbon is 1,400, and then 7,000 and 22,000 and 70,000. Very high indices. And a gas is having a, this is show the scale effect of the global warming due to these gases. So for us, it's something very close to our lives. And 25 times of the CO2, the massive significance and consequences caused by this methane gas. Methane gas is on a day-to-day basis. This is related to wheat and crop farming and also livestock. And in terms of the area of forestry and fishery, this is 2022, the CO2 emission about 1.1 million tonnage, 1.1 billion tonnage, excuse me. Out of that, in terms of the enteric fermentation of livestock, is quite large. And this number, as you see, so many tonnage is a fermentation of the livestock with the GHG methane gas is being emitted. It is quite a surprise. On the right-hand side, the illustration, as you can see. So this is a burp or fart of a single cow, and the methane gas is per day 200 to 600 liter per day, only from a single cow. Annually, so 3 billion tonnage. So all the methane gas from burp and the fart of the livestock cow, and the CO2 equivalent, that is going to be globally, this is the about 5 to 7% of the total greenhouse gas. This is leading to the global warming. And this GHG that is expanding, and emission of that leading to the global warming has a negative effect on the ocean as well. Of course, the temperature of seawater will rise and have a significant effect in the species under the water. So in terms of rocky shore, the inundation, coral bleaching, and decrease in fish catches are also something that is well known. The temperature rise of the water and the sea, the fish and other underwater vegetation are being affected, and they are chased out from where they can live, or there are some whitening or bleaching effect of the coral, which is done due to the ocean acidification. So these are, of course, the fact that the planet is encountering with the large GHG emission, and also the severe consequences of the destruction of the marine environment. The kagi, which is meaning key, this is the red algae. It's called kagike nori, is the name of a seaweed. So kagike nori is a characteristic. Asparagopsis is the English name, taxiformis, and the white sort of red-purple, it's a kind of herb. And the characteristics is the very small, hairy, fuzzy seaweed. And the area is distribution is the tropical to subtropical region. In Japan, is that in terms of Kyushu and Honshu Pacific area, the southern area, Nansei Island, Ogasawara Island, and Goto Islands. And this kagike nori and this relationship with the methane gas emitted from cow. Inside the stomach, there is a methane sort of bacteria residing within cow. And the methane bacteria, we can shut down the methane gas emission. So draw home is an effective sort of ingredient that is going to stop the methane generation within the stomach and intestine of the cow. So our thinking in terms of the kaginowa, the key of kagike nori is that in social implementation, 1 cow per day, 10 kilograms they would consume as food. And 0.2% of this seaweed could be fed together. Then over 90% of methane gas could be reduced from a single cow. So this is the data point that we do have. So in terms of the in vitro testing, 99% methane gas could be reduced, and we have confirmed this. So On the on-land cultivation, we are going to expand, and in-water cultivation in Kagoshima Prefecture, Yamakawa Fishery Farm also conducting a underwater cultivation. So all the fishery people and the community of the region, we could lead to the generation of new industry. And the feed for the cow, in terms of the additive, we have to register as an additive to the feed for the cow and livestock. And we're on the process of doing so, and we'll be able to complete that within this year. So methane gas, reduction of that, we've done J credit. Kagikenori, those purchaser of this feed, inclusive of asparagus kagikenori, we will be able to pay back. So that's the circular system that we would like to create. So therefore, kagikenori, in culturing them, first of all, the methane that is emitted from cow is going to be reduced, and kagikenori is going to be cultured under the water. So CO2 reduction in water also could be achieved. And furthermore, we will be able to revive the underwater ecosystem and the species that live in the water. So this is a Kaginuma project with a methane gas reduction within the circular environment is what we like to achieve. So this is the project that we're working on here in Japan, and our homepage is not yet prepared yet, but please let us know if you are interested. So thank you very much for today. Thank you.
ありがとうございました。続きまして特定非営利活動法人クリーンオーシャンアンサンブル
Next is a Clean Ocean Ensemble.
皆さんこんにちは。クリーン
Good
NPO 法人
afternoon. My name is Takuya Yasui, board member of a Clean Ocean Ensemble, which is an NPO. So JICA former volunteers got together and formed this NPO. And from January 2017, I spent 2 years in Maputo, Mozambique for JICA activities as a volunteer. This is our vision and mission. We want to achieve world of zero marine debris. Shodoshima Kaga Prefecture, this is where we are. And the projects include Maputo and Vung Tau in Vietnam. I would like to explain about the problem of marine debris. And I'm sure that you are familiar with most of this already. Environmental impact in the ocean, and also economical impact in terms of tourism, fisheries, and aquaculture. About $13 billion of annual loss has been calculated due to marine debris. In order to solve these issues, we need to understand how much we need to collect and how much is actually being collected. But this information is not available. This is one of the reasons why this is challenging. We propose 2 solutions to address this issue. First of all, collection system for marine and river debris, and the second is a map of marine and river debris. I'll start with the collection system for marine and river debris. There is natural tide, natural flow, which can be leveraged. We introduce anchors, buoys, and net to formulate the collection system. It's like a volleyball net, submerged underwater. And this means that debris floating on the surface only will be caught by the net, and the marine creatures can escape. And the captured debris will be collected in the collection area, so it will not float away. And using the natural tidal current, we can capture the debris naturally and collect them with the system. In Shodo Island, Kaga Prefecture, we are working with local fishermen to install the system. So in terms of design, structure, location of the system, we got insight from the local fishermen. Other than beaches where a lot of people gather, marine debris is seen a lot in, for example, unmanned island, as well as areas where people do not really visit. So by installing the system close to these areas where there's a lot of beach debris, we can collect debris, increase the volume of a collection of marine debris. We have also developed a collection system for river debris, which means that we can stop the debris from floating from the river into the ocean, which will help increase the volume of collection. And this is the second solution, which is a marine and river debris map system. Picture of the debris collected, geographical location, and the time, and also sponsor company information are fed back into the system. It's very simple to use. Only 3 steps are involved. You collect debris, and then you take a photo of that debris and upload the information. And the uploaded photo will have time and location data attached. So that part is automatic. Collection efficiency can be improved through this system because the collection system that we introduced has to be installed in areas where there's a lot of marine debris. But we never really had information about where the hotspots are. Sometimes beach cleaners and fishermen collect the debris, but we don't have information about where the debris is being captured and when. So by collecting these different pieces of information or data, we can identify the actual hotspots highlighted in red on this map. By visualizing the hotspots, we can increase the efficiency of collection. So, for example, the cleanup campaign can be conducted in the hotspots. Or if we know that the debris is flowing according to this red arrow, we can install a collection system along this line to collect the debris efficiently. Next, I would like to talk about the business model. Carbon credit type of concept is applied. So certificates of credit can be issued for charge, and this can be used for financing to increase the number of participating companies. And we can incentivize the collection of data so that we can increase the volume of collection of debris. So by turning this into a business model, we can involve more companies as well as the government in order to accelerate the speed of solving the problem. Now, this solution was actually applied in Mozambique. The project started in April 2024. Marine debris issue is global, so we want to understand how long and how much cost it will take to this project and what the process is required. So the collection system was designed and prepared with cooperation of local fishermen, and we conducted 2 demonstration tests in the ocean so far. And again, Ministry of Fisheries provided us with an agreement as well. Effectiveness of this system in overseas applications and also demand outside of Japan were confirmed through these demonstration tests. We also did this demonstration test in the river as well. We have confirmed that this system worked, and this project was conducted with the cooperation of the local city hall and the police. Our organization is 5 years old, and we are addressing the challenge with the support of many different organizations and companies for the world with zero marine debris. This is a big cause, and we know that we cannot do this alone. So that is why we say Ensemble together to tackle this problem. Thank you very much.
Thank you very much. From ALN, please, ALN Corporation.
Hello. First of all, have you heard that the ocean plastic waste is increasing every year, like the photo up here? And did you know that the most common ocean plastics waste is from fishing gear? And there's also a problem that the fishing net dumped in the ocean will cause harm to marine life. Well, but is this fisherman's fault? Well, we don't believe so. We think this is a system error. The lack of proper recycling system leaves fishermen with no choice but to throw it as industrial waste or throw it in the ocean. So our aim is to tackle this fundamental issue through our business. We are turning waste fishing net into a resource for the future by purchasing it from the fishermen and then upcycling them. So hi again, this is a business, and my name is JICA, and I'm from a company called ALNUR. We started our company in May 2023, and we are based in Miyagi Prefecture, Japan. By the way, the photo here is our port town, Kesenuma, which we are based in. And here is our team member, including myself, and we are all from different backgrounds and different regions, but we met at Kesenuma City and started this business. Our vision is nothing is worthless, and our mission is weaving a new chapter for the community. Well, back to the beginning. So how are we turning these waste fishing net into a resource? Once we upcycle the net, we are developing a recycled nylon material brand called ALNUR Co. And what is ALNUR Co? The key feature of ALNUR Co includes the use of 100% recycled material dried from fishing net, traceability of which fishermen's nets are being used in the recycling process, and contributing to biodiversity. Here is the process. First, we collect waste fishing net from the fishermen and then chemically recycle it back to raw material and generate ALNUR Co nylon, which will then be pellets, yarns, and fabric. And then we will be selling this to B2B market, for example, fashion brands and outdoor brands. After customers have used their product, we will again collect them and recycle back again into raw material, aiming to create a circular economy starting from the fishing net. In this business model, the key factor is how efficiently we can collect the net. So We have been physically going to ports all over Japan, from Hokkaido down to Okinawa. And we have actively expanding our connections with the fishermen, local fishermen. And sometimes we do sorting out fishing net, and then create a customized collection plan for each region. This is the photo from our warehouse in Kesennuma. And these are all the waste fishing nets, and we still have a lot more. After all the recycling process, our sustainable material will be pellets, yarns, and fabric, as I said before. And these can be used in a wide range of products. For example, jackets, bags, and sunglasses, and many other more. Today I brought this sunglass, and this is actually made out of our recycled material. Not only providing the material, but also as a further service, we provide a tag, special tag, that for products that are made with ALNUR. These tags come with a QR code. And then if you scan this, you can access to the story behind the product and the traceability details. You can see whether where the nets were collected and how it was recycled, and then how this became to the final product that reaches you. And this helps bring fishing and fishermen closer to everyday life and give people a new reason to choose an environmental friendly product. Moreover, we are challenging the circular economy, and these products are not just single use, but are transformed into new items for the next generation. We are also exploring features like repair tags and systems that encourage intergenerational use to promote circularity. And as another challenge that we are working on is fishing nets that cannot be recycled into fabrics or yarns. We will reproduce it into tiles through a special recycling method. This is a photo showing a recent example of our ALNUR tiles being used in a restaurant in Sendai. They were installed on the wall behind the beer server. For this tile project, we mixed glasses, a glass from the local sake bottles and local fishing net, and create a unique pattern. So last year, we built a connection with fishing communities around Japan and collected 50 tons of fishing nets domestically. For this year's goal, we want to double the number. So we want to collect 100 tons of fishing nets in Japan, and also putting more efforts into expanding our ALNUR sale. For 2026, we are aiming further increase of our collection volume to 300 tons a year. And we also want to look to go globally, starting fishing net collections overseas. As a startup, currently we are in the seed round, and we are now seeking passionate individuals to join us to accelerate our business. Whether as a partnership or as a part of a team, we are welcome to those who share our vision to get involved. Lastly, there is a number 600 years, which is said that the time it takes for fishing nets to be naturally decomposed. We aim to reduce this 600-year process by considering it as a resource, adding substantial value to it, and delivering it to the world. Last but not least, we weave possibility turning waste fishing net into a resource for the future. That's all from us. Thank you very much.
ありがとうございました。
Thank you.
では最後にファブラから
Last but not least, we have a fabula. The floor is yours. My name is Oishi with a fabula. Our vision is to create something that is emotionally moving from waste. So cabbage, outer leaves that get wasted, citrus skin, onion skin, these are food waste. And we turn them into objects and building materials. That's the technology that we provide. So rather than just processing, dealing with waste, turning them into something that is more attractive, like objects and building materials. That's our vision. And one of the problems that we can solve with technology is dealing with the issue of food waste. I know that other companies have already talked about this, but food waste disposal is maybe turning that into fertilizer or animal feed or just disposing, but still they generate a lot of CO2, and sometimes it doesn't really achieve the return on investment. So when we speak to food manufacturers, they tell us that they sometimes spend hundreds of millions of yen to deal with food waste every year. This is our technology. Looks really simple from this slide. So we get food waste as a raw material, and we basically dry and grind that into powder, and then we use something called hot press. So heat and pressure are applied. This is a very traditional, old-fashioned technology, but by using the hot press technology, we can create new materials. One thing we can say about these materials is that the color and the fragrance of the original material can be leveraged. As you can see on the slide, top left is tangerine, orange. If you use purple sweet potato, it becomes purple. If you use tomato, like you see at the bottom, it's redder. If you use coffee, then you can actually smell coffee in the resulting material. These colors and fragrances can be taken advantage of to create a new creative space. So we want people to realize that food waste is actually very attractive as source for materials. Now, another characteristic of food waste is that actually food waste is strong enough to be used as construction material. There is tensile strength or bending strength, and you can see that using any of these materials, any of these wastes, it's stronger than concrete. At 5 millimeter thickness, Chinese cabbage can bear 30 kilograms of weight, which is 4 times as strong as average concrete. So these raw materials can be used as construction materials as well. Machida-san developed this technology as a graduation project from the University of Tokyo, and this was the first startup from the University of Tokyo. There is a patent that is related to this technology as well. We are figuring out the business model depending on the situation through discussions, but we want to be fabless. There are 2 things that we are looking into, or we're looking at. The technology is simple. We're just assembling traditional technologies, which means that you don't need to build a new facility. So the fabless model is possible. And also this means that you can manufacture and consume locally where you are. Food waste, when it's transported, would emit additional CO2. But we can avoid that by using the local waste and turning that into materials that can be used locally. We have factories in Kansai, Hokuriku, different parts of Japan, where the local waste can be turned into new materials. So that's the business model that we are pursuing. These are some of the things that we have actually made. This was a prototype. This is a stool that can be assembled. So the seat surface is made from coffee, and the legs are made from Chinese cabbage. The concept is that all these materials are available locally. And also, this can be assembled depending on the taste of the final user. So we thought this was an interesting concept. And then this is the building material, tiles. 300 millimeters square tile. Burdock, Chinese cabbage, coffee. These are the different materials that are used. And on the right-hand side, what you see is bread used as raw material to make the tile, but this material can be formed almost like wood, which means that depending on what the local requirement is, you can produce different surfaces or textures like this. There is a big project that is going on right now. We will be part of the Osaka Expo 2025. Kengo Kuma, the famous circular structure, we're actually outside of that. You can see the small red circle. This is where our gallery will be. The gallery will be using our material. This is what the gallery will look like. We'll be using tea leaves and the cacao husks and other materials. And they'll be used as a roof or ceiling material, value-added ceiling material. And also in Italy, together with Mitsubishi Jisho, and also in Dubai, we are building structural materials together. And Karimok Furniture Company is also working with us. We produce some interior goods for Milano Salone. So our products are gradually introduced to markets outside of Japan. Exhibits in Italy and Dubai are captured by our Instagram photos, so please take this opportunity to follow us and enjoy the pictures that we can show you on Instagram. Thank you for your kind attention.
Thank you very much. Thank you so much for your kind attention. With your kind cooperation, we were able to conclude before the time schedule. Thank you for your cooperation. This covers all the presentation and companies who had provided us with your business pitch. Thank you very much for your kind cooperation. So all the program has been concluded at this blue stage.